I often thumb through all my old schematics in my archive. And that's also the reason why, when you have followed my channel, have seen that circuit that I published yesterday or 2 days ago, and I found another circuit in my archive, and that is this 2-transistor Sawtooth generator. I think it's an interesting circuit. The good thing is that it always works. Another thing is that it gives out this type of sawtooth. So there is here, say, a certain time in between before the second sawtooth starts. So the voltage goes up, suddenly falls down. There is a kind of time delay here. Then it goes up again, falls down, and again that same time delay. But anyway, could be an interesting circuit. And that's also the reason why I publish it. There are a few things to tell about this circuit. Here you set the frequency. This is a resistor that in a certain way protects the transistors and also limits in a certain way the frequency band. But anyway, the whole circuit is in fact a classical A-stable multivibrator. In the past made with tubes, now it's made with 2 transistors. Well, this is perhaps interesting to tell. There is a fine-tuned potentiometer here of 1K, that is 1000 ohms. And when you turn it to the left side or turn it to the right side, you will get completely other frequency ranges. So that's important to tell. And here are these 2 different frequency ranges. When the fine-tuned potentiometer is set to a certain position, you get this frequency band, and also related to the supply voltage. Always important with A-stable multivibrators, that is that the supply voltage has an enormous effect on the frequency, and that's completely logical when we look at the electronics theory. So this is table 1. With that potentiometer set to a certain position, you go from 1.4 kilocycles up to 4.7 kilocycles on 18 volts here and on 6 volts here. But when you move that potentiometer to the other side here, you have a very big frequency band. 6 volts, 8.2 kilocycles to 14 kilocycles, and on 18 volts from 1.4 kilocycles to 18 kilocycles. Anyway, I think that's good information. I made it here, by the way, with ceramic capacitors. And when you want to use this this circuit in a serious application, don't use ceramic capacitors here. Use foil capacitors, because these capacitors are normally temperature sensitive. So let's look what the circuit can bring on the scope. By the way, of course, when you change the value of these 2 capacitors, you go to other frequency bands. Say 10 nanofarad here, or 470 nanofarad, 10 nanofarad. You will get to higher frequencies. 470 nanofarad, you will go to lower frequencies. That's completely logical. Test, try, develop, etc. Well, now on the moment it's on 18 volts. Let's see what happens when we put on the scope. And of course that's a good thing of my scope. It also has a frequency counter at the same time. And that's very good from Handtech. Well, now we are on 17.4 volts. Here is the schematic. Switch off all the lights now. You see the typical waveform. So the time in between here, it's now 25 kilohertz. Well, that's quite high. I didn't indicate it in my tables, but anyway, I think test, try, etc. I change now the 10K potentiometer in the circuit here, this one, that sets the frequency. Let's see what happens. And now the 1K potentiometer is turned to one certain position, one of the two positions. When I go with my hand here, you will see the hand effect. Again, when you want to make it for a serious electronic application, make it in a metal box, etc, etc. So, change the frequency. This is the lowest frequency that the circuit can bring now. There's not so much change in the waveform. And this is now 1.55 kilohertz. Turn up the potentiometer again. You see that the output level drops. Well, in a certain way that's logical. And now we are on 19 or 20 kilohertz again. So now I want to go to 12 volt to show what is happening in the circuit. Now it's 12 volt, and like I told, the A-stabile multivibrator, there's a direct relation between the supply voltage and the frequency. Anyway, now I'm on 19 kilohertz. Turn that 10K potentiometer again to the lowest frequency that it can bring. 2.2 kilohertz. Well, anyway, I think it's a very good circuit to do experiments with. You can use it for all kinds of applications, measurement applications, etc, etc. I don't want to go too far and say demonstrate more. That's what I mean anyway. So perhaps we can go to 6 volt. That's perhaps interesting to show again. 6 volts. And now we are on 1.4 kilohertz. Turn that 10K potentiometer again. We are on the highest frequency giving out at 6 volt. That is 5.7. Oh well, it's 12.1 kilohertz. Thanks for watching. Very interesting circuit. You can make it on the breadboard. Doesn't take much time. Could be very useful for all kinds of electronic applications. Driving a transistor, driving say an high frequency coil via a Darlington or via a transistor, etc, etc. Pen over somewhat again. Show the schematic again, and again thanks for watching.